Hello everyone. In this video we will see about differential leveling. In the last video we saw about simple leveling. Now if the same points A and B are very far apart, let us say the distance is like 5 kilometers, then with simple leveling with one instrument at center, if you try to look at this point, the staff reading will be very small to look. So it is very difficult to go for simple leveling in this case. So what you do is you go for differential leveling, which is nothing but you will have to change the instrument point at 2 or 3 times. Let us say you know the reduced level of point A, and now you want to find out the reduced level of point B. So what you do is first you keep an instrument here, leveling staff here, try to sight this point. Now you go for another point, let us say it is D. So you keep a staff which is nearer to the height of instrument so that you are able to see the reading. Now you keep the same staff level at D. Now you change the instrument at some point here, and from here you try to sight at D and then sight at B. Now you will know the difference in levels, and then with some computations you can find out the reduced level of B. So for this there are two methods. One is height of instrument method and another is rise and fall method. In this video we will see about height of instrument method, and in the next we will also solve one problem. In the next video we will solve rise and fall method. Now let us say the same example we will take. You have point A and here you have point F. Now you want to know the reduced level of F, given that you know the reduced level of A. First we have to draw, let us draw a table. Because we have different stations, we have a station column, back side, intermediate side, foresight, height of instrument and reduced level. These are the different columns. Now let us first keep the instrument at some point here. So always first reading is the back side. So at station A, let us say the back side is S1. You know the reduced level at point A as HA. So what is height of instrument? It is nothing but reduced level at A plus S1. Now you have some intermediate sides. That is just to confirm the readings. So let us say the intermediate sides are S2, S3 at point B and C. Then you have point D where you have the foresight, which I am denoting as S4 here. So the staff reading at point D is S4. These are B and C. And similarly we have points E where you have some intermediate side. So that I am denoting as S5, and the final reading foresight at F point is S6. So now you know the height of instrument at point A is reduced level of A plus S1. If you want to know the reduced level of B, it is nothing but height of instrument at A minus S2. At C it is height of instrument of A minus S3. And similarly at point D it is nothing but height of instrument of A minus S4. You have changed the instrument here, so you need to have another back side also. I am denoting that as S7. So height of instrument of D is, it is nothing but reduced level of this point D minus plus backside. S7. You always know height of instrument is reduced level plus backside. And similarly at point E, reduced level is nothing but height of instrument of D, that is at this point, minus S6, sorry S5. And here it is height of instrument of D minus S6. So this is the final reduced level of point F which you need to know. For checking purposes, what you can do is you can sum up backside. You have sigma backside and you can sum up foreside, that is sigma foreside. So sigma backside minus sigma foreside equal to last reduced level, that is at point F, minus first reduced level, that is HA, minus first reduced level, so that you can know whatever calculations if you are doing is right or not. So you need to know it just 2 points. Height of instrument is nothing but adding backside to reduced level. So here you have RL of A, reduced level of A plus backside S1, reduced level of D plus S7. So you have height of instrument. Elevation of next reduced level, that is next reduced level is nothing but height of instrument minus foreside. If you have intermediate side, you can replace foreside by intermediate side. So you have HI of A minus S2, HI in height of instrument of A minus S3, similarly minus S4 here. Here you have changed the height of instrument, this is change point. So it is height of instrument of D minus S5 and this is height of instrument of D minus S6. This gives you the final reduced level of point F. Now let us see one example to get it more clear. Here they are given that a leveling is carried out to establish the reduced levels of point R with respect to the benchmark at point P. So they have also given the staff readings at P, Q and R. Now first let us draw a table so that we do it appropriately. In exam you can solve in any faster method, whichever you feel is right. So what are the stations here? We have P, Q and R. So first let us copy these values here, 1.655 minus 0.95. Please be careful with the signs and make sure you use the minus sign, 1.500 meters, and at R it is 0.75 meters. You know the reduced level at point B is given as 100 meter. So what is height of instrument? Height of instrument is nothing but reduced level plus backside. So 100 plus 1.655 equal to 101.655 meter. So this is the height of instrument at point P. Now we have elevation of next point. So elevation of next point is nothing but height of instrument minus foresight. So 101.655 minus, so minus foresight. Here already it is minus, make sure you copy the minus sign also, minus 1.5. This becomes plus and you get it as 103.155. Now they have changed the instrument at Q, which is known as the change point. So here height of instrument of Q, we have reduced level at Q plus backside at Q. So that is nothing but 103.155 plus the value of backside, which is minus 0.95. If you solve this, you will get it as 102.205 meters. Now what is the reduced level at R? It is nothing but you have height of instrument minus foresight. So this height of instrument is 102.205 minus 0.75. If you solve this, you will get the answer as 101.455 meter. So this is the reduced level at R. If you want to check the answer, what should you do? It is nothing but you have to sum up backside. sigma backside, and you have to sum up 4 sides, sigma foreside. Then you should do sigma backside minus sigma foreside. So that is 1.655 minus 0.95 minus of minus 1.5 plus 0.75. This is sum of 4 sides and this is sum of backside. If you solve this, you will get the answer as 1.455 meter. This should be equal to last reduced level minus first reduced level. Here the last reduced level is 101.455 meters minus 100, which is equal to 1.455 meter. So this value and this value are same. So whatever process you have done is correct. Thank you guys for watching the video. In the next video, we will see about rise and fall method.